All right, welcome back. Um, Good to see you all. I know some of you have recitation on Tuesdays, some on Thursdays, so um, I know this gets to be a busy time of the semester. Our next test is the final exam, so we just keep moving forward with the content. Keep recording, so if you're not able to make it to a class, please be sure to take a look at the lecture on recorded version. Where we're at is we're in Module 5. We're going to look at sum and difference formulas, which will tie in with what we'll do on Thursday, which is double angle formulas. And you could think of a double angle formula as just a angle plus itself, right? So the techniques we're going to look at today, we'll just kind of go over on Thursday. We'll start looking at some equations. Then there's a law of sines and law of cosines. So we're really on schedule to be wrapping up trigonometry fairly quickly. So these next ones will give us some practice with working with some of these things. So we're going to go ahead and go into the sum and difference. There's some additional resources here to help out as well. And see if there's any questions. So sum and difference formula. So this is if we have two angles that are being added together. So I'll just show you what those formulas are. What are they? Here they are. We're not going to derive them or anything, but you could go through all the algebra or the geometry of how it works. But there are these formulas that if we want to find, oops, let's get my writing utensils back up and running. There we go. So all of these work very similarly. If we want to find the sum of two angles that are added together, we have this identity that we will get the same value if we use this formula as if we tried to do this. So we don't necessarily need to know the angle. Also, if we're going to subtract two angles, we have a formula for that. We have the formulas for cosines added and subtracted. And then we have the tangents for two angles added or subtracted. What this allows us to do, the way we're primarily use this for, is remember we have the three angles, the three special angles. I guess there's actually 5 of them, 0 and 90, but those I don't really count. But I guess we could. 0, 30 degrees, 45 degrees, and 60 degrees. And I guess we could throw in there the 90 degree. We know exact values for these on the unit circle. So what this will allow us to do is if we can combine them in a way, say 30 degrees plus 45, that's going to be 75 degrees. We can actually get an exact value for a 75 degree angle with one of these formulas. Okay. What else could we do? Well, we could add 30 and 9 or 30 and 60, but that gives us 90, so that's not helpful. But we could also go with 45 degree plus 60 degree. So now we can do a 105 degree angle. We can get an exact value for that if we needed it. We could also use these for other things, but that's basically what we're going to use it for. We could use the subtraction ones, so we could do like 45 degrees minus 30 degrees. So we could actually get us the exact value for a 15 degree angle. And then the other one, we could do 60 degrees minus 45 degrees. Oh, that's also 15 degrees. So there's two different ways to get to the 15 degree. Right, subtracting one of these. We could do 90 minus 60. That would give us 30, so that's not going to help us all that much. 45 minus 30, that's 15. 60 minus 45, that's 15. 60 minus 30 is 30. So we're just looking at the ways we could combine these to get sort of a new angle that we don't have the special angles for. So these are kind of really the only additional angles that this allows us to add as far as special angles. But we'll also see, again, basically after this, we're just going to work several examples, and we'll see how these all work out. We're going to just We don't have to memorize these. We will provide them, I believe. At least that the formula sheet I've seen it has all of these angles in there. So we don't, it's not a class on how well can you memorize things, but how can you apply these formulas. So we may jot back to one of these, but you kind of see the add is sine A cosine, so sine and cosine, cosine and sine, changing the angles, added. Adding is adding, subtracting is subtracting. When you get to cosine, adding is subtracting and subtracting is adding. So you just kind of pick up the way the formulas are a little different, but as we use them, what I'm going to do is I'm going to go back. I will rewrite them because as I write them, they'll help me remember them a little bit better. And it just, if you remember something, it's easier to work with. The tangent ones are a little bit more complicated, but again, I wouldn't try to memorize them, but you can kind of see the patterns. The A plus B, in the numerator you're adding, you subtract off in the bottom, and the subtraction you subtract in the top and add in the bottom. So I'm not even sure we're doing it. So here's the thing, is we're given find cosine of 105 exactly. They don't tell us which angles to use, but you've got to think, okay, 105, remember, look at that other one. How could we get 105 with one of our special angles? See, 60 plus 40, or 40 plus 60, or 45 plus 60, right? So if I take a 45 degree and add a 60 degree angle, that will give me cosine of 105, 60 plus 45. So I could use this, and again, you could change the order because it's commutative. You could put the 60 first and the 45. What we need to do is go back to that formula. So I'll back up here. We're now, since we're doing 45 plus 60, I want to use this one. So it's going to be cosine of the first angle times cosine of the second angle minus sine of the first angle, sine of the second one. Okay, I think I can remember that long enough to come over here and say that this is going to become cosine of 45 degrees times the cosine of 60 degrees. And since the plus, it goes with the minus sine of 45 degrees times the sine of 60 degrees. Okay. So that's the first step. Second step is now we need to know what these values are from the unit circle. So again, we might look at our unit circle if you've got it sitting around, or try to remember what is cosine of 45 degrees. Well, that's square root of 2 over 2. What's the cosine of 60? 1/2. Is that right? And again, these are just coming off the unit circle. If I've got a wrong one, you guys might be better at this than I am because I don't review all of these all the time. I'm not, but from doing the homework problems, you should probably be picking these up. Sometimes I'm a little off, but and then sine of 45 degrees, well, sine of 45 degrees is square root of 2 over 2, and sine of 60, that's the one that's square root of 3 over 2. Okay, and now we're going to arithmetic, right? We're going to multiply fractions and then maybe subtract them with a common denominator, but a lot of times, in this case, we're going to have a common denominator. So we multiply the fractions, square root of 2 times 1, and remember, when you multiply fractions, you multiply straight across the numerators and denominator. So this first part just becomes the square root of 2 over 4. This second part over here, square root of 2 times square root of 3, is going to be the square root of 6, because you can bring them inside. 2 times 3, basically the square root of 2 times 3, so square root of 6 over 4. And now when you're subtracting fractions, they've got a common denominator already. That's good. And so we get square root of 2 minus the square root of 6. Notice this value you could see is going to be negative, right? Because square root of 6 is bigger than the square root of 2, so we're subtracting, we've got a negative. Where is this angle? 105 degrees is in the second quadrant, right? It's a little bit bigger than 90. Cosine should be negative in the second quadrant. So there's kind of ways you can check your answers if you're in the right ballpark and stuff. So remember, we're getting the cosine of 105, so that's 90 plus a little bit more. We're in the second quadrant. Cosine should be negative, so we're feeling good, hopefully. So is that first kind of is that first one okay? Okay, and again, we just used the formula. Where did the formula come from? I don't know. Somebody worked on, who was into trig, worked on it a lot. But again, if you were math majors, maybe we do that, but you're engineering majors. You just want to know how to use the technologies, right? And that's what engineers do. Okay, so we give you this. Mathematicians derive the formulas. Engineers use them to create a better world. All right. Now let's think of this one. This is pi over 12, so we have to be able to work both in degrees and in radians. How can we get pi over 12? And basically, remember, since they wanted exactly, it means we have to have an exact angle. What are our angles? Well, we've got pi over 3, we've got pi over 4, and we've got pi over 6. So how are we going to get to pi over 12? First of all, are we going to add some angles or are we going to subtract some angles? We got a small angle. How do you get small angles from bigger angles? You got to subtract. So our mind's first going to subtracting. Well, how do we get pi over 12? None of these have a denominator of 12, so what could we do to see which ones we would use? Could we turn each of these into a common denominator of 12? I think that might be the route to go. So pi over 3, to have a denominator of 12, I need to multiply by 4 over 4. 4, to turn it into 12, I'm going to have to multiply by 3 over 3. And 6, I'm going to have to multiply by 2 over 2. So the other way to think of this is 4 pi over 12, 3 pi over 12, and this would be 2 pi over 12. So, and then if we subtract them, notice I could use either this first one, 4 minus 3 would work, but also 3 minus 2 would work. So I have some choices here. I could do one way, you could use the other ones. We should get the same answer. So multiple ways, which is always nice. Which one do you want to use? Which pair of, anybody have a preference? Which one? 4 and 3. Good. Those are good numbers. 4 and 3. So we'll use the 4 and 3, so we'll use this one and this one, which again is, when we set it up, is actually going to be pi over 3 and pi over 4. Okay, but we can see if you take pi over 4, or 4 pi over 12 minus, let me just do this. So 4 pi over 12 minus 3 pi over 12, we get 1 pi over 12. Okay, so these two work, so we're going to use pi over 3 minus pi over 4. Did I get that right? Yeah. Oh, yeah. Okay, I was thinking pi over 3 comes first, but pi over 3 is up here. It's the bigger angle. I had them backwards in my mind, so something. But, okay, we're okay. So, what we're going to say is that sine of pi over 12 is the same thing. And again, maybe we'll back up a couple. Okay, sine when we're subtracting, this is the one we're going to want to use. So we want sine times cosine, cosine times sine. So sine of the first angle, cosine of the second angle. Cosine of the first angle, sine of the second angle, and they're subtracted. Okay, so we kind of get that burned in the back of our retina so we can never forget it. Oops, I'm going the wrong way. Let's see if I can, I've already forgot it. Okay, so this is going to be, oh, actually, let's set it up this way. This is going to be sine of pi over 3 minus pi over 4. And we did it with the 12s. We know that that equals to that. Okay, so we've already done this. This is what we want. So we use our difference of angles formula. And what was it? It was the sine of the first angle, pi over 3, times the cosine of the second angle, pi over 4, minus cosine of the first angle times sine of the second angle. Did I get that right? Heck, if I should know, you're the teacher, right? You should. Okay, so we'll backtrack again, because if we don't have it set up right, we're not going to get the right answer, right? So why do all this work if we, let's check it again. Sine of the first angle, cosine of the second, that's what I did, minus cosine of the first angle, sine of the second angle. Let's go this way. Okay, first angle, second angle, first angle, second. Okay, we're good. And again, just like the last one, we go to our unit circle now because we want the exact values, and we pick out our unit circle values from this. So what's sine of pi over 3? That's that one up there. It's getting bigger. I think that one is square root of 3 over 2. Cosine of pi over 4, that's our 45-degree angle. I like that one because both of them are square root of 2 over 2. And then I've got the subtraction. Cosine of pi over 3. Cosine of pi over 3, that's the one that's up there. That's the one that's shorter. So that's 1/2. And then sine of pi over 4, that's, again, that's a 45-degree. That's the one I like. It's square root of 2 over 2. It's the one in the middle. Got my exact values. Multiply the two fractions. Hopefully they'll have a common denominator, which they will. And then I just add them together. So square root of 3 times square root of 2 is square root of 6 over 4. 1 times square root of 2 is square root of 2 over 4. 2 times 2 is 4. We have a common denominator, so we can write them all over this common denominator. And we get the square root of 6 minus the square root of 2. And knowing that the square root of 6 is bigger than the square root of 2, when we subtract them, we will get a positive value. Pi over 12 is in the first quadrant, so that's good because we have the sign of pi over 12 in the first quadrant should be positive. You know, so just kind of a quick check on that. But that's what it is, and that's an exact value. Second option. We okay with that? So subtraction, addition. You play with it. You might have to get some common denominators if we're doing with the radians. But again, it's really just, that's all there is. We go back to the formula. We're just going to be able to use it. There's a couple tricky ones, and this is the first one. We'll start off with the tricky one. This is not one of our special angles. I don't think. Maybe it is. Square root of 2 over 3. Yeah, we have a square root of 2 over 2. That's one of our special, but not square root of 2 over 3. So with these ones, what we're going to see is, and again, we've got actually 3 different things, so we're going to use 3 different ones. With these ones, we may not actually find out what the angles themselves are, but we will find out what their values are. Does that make sense? So this one tells us cosine of alpha is equal to this value. We're going to be using this, but we'll also, if you know this with the cosine and the sine, we're also going to need to know what is the sine of alpha. And for the tangent, we're going to need to know what the tangent of alpha is. So what we'll start off with is, if we know cosine of alpha is equal to square root of 2 over 3, what does this tell us right here? It tells us something about the angle. tells us which quadrant the angle's in. Which quadrant is the angle in with that information? Fourth, good. So we know we're in the fourth quadrant with this angle. Cosine's going to be positive, which it is, but what is sine going to be? Sine's going to be negative. What is tangent going to be? Tangent's going to be negative. Okay, so we gotta, now we're getting into the difficult stuff. Okay, so this is telling us fourth quadrant. Cosine's positive, that's good. But when I go to the sine of alpha, I know I'm going to get a negative. And when I go to the tangent of alpha, I also know I'm going to get a negative. What I do is, how do I get those values? Well, I can kind of draw it, right? We've got alphas down here. Cosine is SOHCAHTOA is adjacent over hypotenuse, right? Adjacent over hypotenuse. So adjacent is square root of 2. Hypotenuse is 3. And so now I just need to figure out the opposite side. Okay, so we see these again, that's why these ones, I have to bring back some of the other stuff I've been working on. So this other side, 3 is the hypotenuse. So 3 squared equals the square root of 2 squared plus, what's that, the opposite side squared? I'll go opposite squared. Actually, I'll do whatever. Yeah. If I just do, oh, it looks like a 0. Let me just do, we'll just call it, x is kind of, because x and y, we get confused. Let's just call it OPP for opposite side. We won't, squared, right? So 3 squared is 9. 2 squared, square root of 2 squared is 2, right? Plus the opposite side squared. Subtract 2 from both sides. We get 9 minus 2 is 7. So opposite side squared. We take the square root of both sides. So we should get that the opposite side is the square root of 7. Square root of 7, if you square that and you square that, you get 2 plus 7, which is 9, which is 3 squared, so it kind of a double check. Okay, so we've got our 3 sides, so now we can get our sine and our tangent from our triangles. Sine is going to be opposite over hypotenuse, right? Opposite is square root of 7 over 3. Tangent is opposite over adjacent, right? So that's, tangent is going to be opposite square root of 7 over square root of 2. Now they usually like us to rationalize the denominator, so maybe we do it here. Square root of 2 over square root of 2. Square root of 2 times square root of 2 is 2. 7 times 2 is 14, so that's the square root of 14 in the top. Okay, so it's all, and it's negative, so remember I've got this part. So both the sine and the tangent are negative. So there's all this work we got to do, but we've got these two things, and remember when we use our formulas, they're going to have sine of alpha, cosine of alpha, tangent of alpha. So, but these are the values we're going to use there. What's the next thing we have to do? Find the sine and cosine and tangent of the beta, and then we'll use our formulas, and we've got all our numbers, and it's just kind of like putting it into the formula. So these are what we're going to use in our formula. How about if it would be okay if I erase my sort of scratch work over here? Again, it's still recorded in the video, but I want to leave myself some space here. So let's clear all of this out. So Set up the triangle. Now we're going to do the same thing with beta, similar thing. Here's our beta. We're told that sine is -5/6, so that's opposite over hypotenuse. And beta, let's see, what angle is it? It's in which quadrant? That's pi, 3π/2, so that's third quadrant, right? So that's what this thing tells us over here, that we are, and I'll switch my, that we're in the third quadrant with sine. Sine is negative, cosine is negative, tangent will be positive. Okay, so we kind of think through these. And I might, if I were, well, I am doing this, right? I'm going to do cosine of beta up here. I know it's going to be negative. I'm going to do sine of beta here, just so that they're all lined up, and that's -5/6. And then tangent of beta down here, and it's going to be positive. So I'm going to put a little plus so that when I get done, I hopefully got everything working. And incidentally, what I'm doing is I'm working the examples from the notes, so you could, if you go to the notes, you'll see them work through these as well. They may do it in a slightly different order or something, but you have those to kind of look at as well. Okay, but this is kind of, let's talk through it, work through it, think through it as we go. So if sine of beta is -5/6 and we're in the third quadrant, let's move that up. I like to draw my triangle here, so here's my angle. I don't know exactly what it is, but there's my beta. So I know the opposite over hypotenuse, so that's going to be 5 here and 6 there. I just need to find the adjacent side, and then I'll be able to get all the other two values that I don't have. Let's see. So 6 is the hypotenuse, so I know 6 squared is equal to 5 squared plus adjacent ADJ squared. So 6 squared is 36, 5 squared is 25, plus the adjacent squared. We will subtract 25 from both sides, and that gives us 36 minus 25 is 11, right? Okay. That's the adjacent squared. Take the square root of both sides. So it's going to be square root of 11. Since we're in the third quadrant, square root of 11 is negative, and 5 is negative because it's down there. That's a y value down into the third quadrant. Is that okay so far? Questions? Good. Okay. So again, we go back to this is stuff. You see with trig, it's narrowed down, but we keep reusing some of the stuff we learned, which sometimes is helpful because you get extra practice with it. But if you're missing this part, this is going to be the heart. But this will give you that opportunity to practice it again before we get to the final. So then we come back, cosine, and cosine is adjacent over hypotenuse, right? Adjacent over hypotenuse. So that's going to be square root of 11 over 6, and it's negative from that. Okay, good. Tangent is opposite over adjacent. Opposite is -5. Adjacent is -11, a square root of 11. Negative divided by negative is going to be positive, so I feel good about that. Rationalize the denominator just so it's ready to go. So we have -5 square root of 11 divided by 11. Okay, so that's our tangent of beta. Okay. A lot of work, and we haven't even really started answering the question quite yet. I mean, we've got all the things we need to answer the question now. So now let's start clicking them off. We want to get cosine of alpha plus beta. Okay, so this will be the A part. Cosine of alpha plus beta. Let's see if I can remember it correctly from the formulas. Remember, cosine is cosine, cosine, sine, sine. And the plus has got a negative in between. So we'll see if we remember this right. So I think it's cosine of alpha times cosine of beta minus sine of alpha sine of beta. And I'm still not that confident, so I'm going to go back to the formula sheet. Cosine of A plus B, cosine A, cosine B, good, minus sine A, sine B. Okay. So we've got the formula set up right. Now I take all those values that I've figured out, plug them in, and we're good. So what is cosine of alpha? Cosine of alpha is square root of 2 over 3. What's cosine of beta? Cosine of beta, negative square root of 11 over 6. Minus, then we go with our sine. Sine of alpha is negative square root of 7 over 3. And sine of beta, I come over here, is just negative 5 over 6. Notice with these formulas, with the fractions that we usually will end up with a common denominator, which is rather nice. So square root of 2 times square root of 11, we've got a negative, so this is going to become negative square root of 22. 2 times 11. And in the denominator, 3 times 6 is 18. And then we'll get a minus here. Notice I'm taking a negative times a negative, so that becomes positive, but this negative here stays negative. Square root of 7 times 5, you can't bring the 5 into the square root, so that's not 35. It's just 5 square root of 7. And 3 times 6 is 18. We have a common denominator, which is nice. So we write it all over 18. And we've got a negative and a negative, so not much we can do. We can put it in either order, I guess. Square root of 22 minus 5 square root of 7. And that is an exact answer, and that's it. We leave it like that. Okay. The trick to this is getting all the values, seeing that, oh, we're going to need all the sine, cosine, tan. Get those first, because that's one way of thinking through things, right? You're making the triangles, you're figuring out what those exact values are. And then use the sum and difference formulas to just kind of fill in once we've got them all. Okay. So that I can stay on this slide, is it okay if I erase the bottom one? Yes. Yeah, if you're going to add them together, we would need a common denominator, but most cases, so far, which I'm afraid to say 100% of the time, but most of the time we'll, because for this angle and this angle, we will end up with common denominators. If not, we'll have to work on it.
Do you know which quadrant we have to be in?
From what they told us at the beginning, up here, and again, notice we are in different angle, that we have two different angles, so we are actually in two different quadrants, but we need to know which quadrant we're in to see if the value is positive or negative. So this first one, which I have circled in red, we were in the fourth quadrant. And so that's what I mean is, if you, while you're doing this, instead of going back and forth, you're in, just tell you, we're in the fourth quadrant, I need all these values. Get all the values. And then for the next angle, it said we're in the third quadrant. So we got a third quadrant angle being added to a fourth quadrant angle. I don't know what angle, I don't know where that puts us, but we're in some other quadrant. Probably, depending upon their sizes, either the first or second quadrant. Because we've got a big angle plus another big angle. We might even back in the third. So I don't know where we are, because we notice we never figured out what those angles are. We just know what quadrant they're in. So that's why, and we get all those values. We never, again, we could maybe go back and figure out what those angles are. That's another way to go, but we don't have to. With this method, we got what the sine and their cosine is. We never know what size angle it is. Okay. Good question. Anything else? Okay. I'm going to erase this because we've got all our values here, and we're just going to use the other one. And again, it's recorded in the video, so if you still had questions, we can back up. But actually, I'll go ahead and take this out because it's just shows you, first you set up the triangles, get all your values, and then you use those values in the formulas. And so for the B part, we want sine of alpha plus beta, and sine is sine cosine, cosine sine. So it's sine of the first angle, cosine of the second angle, plus sine, cosine, cosine, sine. Cosine of the first angle, sine of the second angle. And again, I'm going to, just because I'm a rookie at this, I want to go back and check my, let's see, sine of A plus B, sine of A, cosine of B, cosine of A, sine of B. Okay, so make sure I got my formulas right. I do. And now I go back to my values. I plug in my values, and just like we were doing. So what's the sine of alpha? Sine of alpha is over here is negative square root of 7 over 3. What's the cosine of beta? Negative square root of 11 over 6. Cosine of alpha, that's over here, square root of 2 over 3. And sine of beta, that's over here, negative 5 over 6. Multiply this fraction straight across. Square root of 7 times square root of 11. Negative times a negative is positive. So that should be square root of 77 over 18. The second part, square root of 2 times 5. Remember, you can't bring the 5 in. It's just going to be 5 square root of 2. But it's a positive and a negative, so this will become negative. And then 3 times 6 is 18. Again, we're very happy we have a common denominator, so we can now write it as 1 fraction over 18, and we can do square root of 77 minus 5 square root of 2. And again, they wanted the exact values, so that is it. Notice we've got to be careful on that first step, because if we mess up there, we're going to mess up with all of these down here. So we got one wrong, but we'll be fine. But just take the time to make sure you're in the right quadrants, you've got right signs, whether they're negative or positive, because it's really hard to go back if you get these wrong to where was the error, because notice there's this 2 different steps. It could have been in one of the other places. So far, so good. And again, it's all based on just having those formulas. I've seen proofs or sort of derivations, and it's all geometric of this angle plus this angle, and I think there's a place for that. There's a time and a place. But once you start using them, see how they work, then those proofs start to make sense. But if we start with that, we're all lost for like the first half. And so we'll start with the stuff that is just this how it works. Okay. We okay? I'm not in any hurry. Still writing? Or can I take it off and then we'll look at the tangent? Okay, and again, just because I don't want to recopy all that. I suppose I could, but take that away. We're just thankful they didn't ask. They could have also asked us for cosine of alpha minus beta, but they didn't do that. But we could do that, right? We could do any of the formulas, but we'll just do what they told us. So then tangent of alpha plus beta. Let's see if I remember this right. I think it'll be 1, is it plus or minus? I think it'll be like tangent of, well, except, okay, let's come, oh, yeah, see, I was wrong. So tangent, you do tangent alpha plus beta in the top, 1 minus tangent of alpha times tangent of beta in the bottom. Okay. I'm glad I didn't keep going because I was way off. I had the denominator and the numerator. Let's see if I get it right this time. So this is tangent of alpha plus the tangent of beta. And in the denominator, it's 1 minus tangent of alpha tangent of beta. Okay, so again, just copying on the formula, and now we just plug in the formula, and we've already got the tangents for alpha, the tangent for beta, and we're all good to go. So tangent of alpha, but notice it's going to be, we got a fraction thing, so we're going to have fractions on top of fractions. This is going to get a little gnarly. So tangent of alpha, we figured out, it's right here, is negative square root of 14 over 2. Plus tangent of beta, that's over here, and that's negative 5 square root of 11 over 11. Notice we do not have common denominators, so this is tangent is really the stickiest one to work with. That's our numerator. In the denominator, we have 1 minus tangent of alpha. Oh, we did, okay, so that's square root of 14 over 2, and that's negative, so make sure you get that over there. And then times the tangent of beta, that's negative 5 square root of 11 over 11. Now here's where the arithmetic will get to be a little bit difficult. So in the numerator, to be able to add these two fractions, we need to have a common denominator. So on this, the first one, we've got 2. The second one, we've got a denominator of 11. The common denominator, 22. 2 times 11. So we will multiply the first one times 11 over 11. The second one gets multiplied by 2 over 2. Let's just do that part first. So I'm going to go down here. So we're going to get negative 11 square root of 14 over 22. This plus I'm going to turn into a minus because I see this subtraction here. So I'm going to turn it to subtraction. 5 square root 11 times 2. So 2 times 5 is 10. Square root of 11 over 22. And while we're at it, why don't we go ahead and just multiply these guys here. This is over 2. So this becomes 1 minus square root of 14 minus, oh wait, no, these are multiplied. I've got a negative here and a negative there. So negative times negative is positive. 2 times 11 is 22, so that's looking good. Square root of 14 times 5 square root of 11 I'm going to, what's 14 times 11? That's 154. So, oh, down here, 150. So that's 5 square root of 154. What we do now, yes.
Why is the 511 over radical 11 over 11? Why is that negative instead of positive?
This one here. Let's see if I got it right. Oh, thank you. Thank you. I don't know why. I made a mistake. I was so careful and I said it's positive, and then I put the negative anyway. Thank you for not letting me get too. Yeah, this negative, it was a stray negative. It should just be 5, right? Because a negative divided by a negative. So good, good. Let's. So this is not. So this is not negative here, which means this is a. See, look at how many errors that caused. This should be a plus because that was not negative, and in the denominator, this is positive, not negative. So I've got a negative and a negative, so this is actually going to become positive here, right? Because this was negative times a positive, still negative, but then I've got this negative. Okay, did I get that right now? Okay, thanks. Yeah. You see how easy it is to make mistakes and how hard it is to not. That's what it is, you know. And it's not overly complicated, but it just. All right. Good, good, thank you. And then I guess one final thing I'm going to just is we're going to combine these two fractions together. In the numerator, we have a common denominator, so we would like to have a common denominator in the denominator. So we see 22. So what I'm going to do is I'm going to rewrite 1, because that's always the easiest one to change, as 22 over 22. If I can. I may be too far down. Okay, we're going to get a single fraction in the top, a single fraction in the bottom, and since when you have a fraction in the top and bottom, it's division, we're going to flip and multiply, and maybe we get some canceling out. I think we will. So in the numerator, and I'm going to write it sort of down here, the numerator has a common denominator of 22, and it's going to be 10 square root 11 minus 11 square root of 14. So I switched the order because of the subtraction is easier to write that way. See, you get some really funky answers. And in the denominator, it's also over 22. I'm going to write it, so we would divide by it, but what I'm going to do is I'm going to invert it as I calculate it, right? It's got a common denominator of 22. I'm going to put that up in the numerator, right, because it would be down here. And then the numerator should be 22 plus 5 square root of 154. Okay, so I kind of did 2 steps there where I calculated what the fraction should be, but I flipped it so that I can just turn it into multiplication. Does that make sense, what I did? And it saves me from writing it again, because every time I write something, I have an opportunity for copy errors, and you see me, I make, okay? And notice what happens to that common denominator. So now this is multiplied. 22 divides into 22. That's 1. And so we get this really funky answer, 10 square root of 11 minus 11 square root of 14 all over 22 plus 5 square root of 154. that is an exact answer. Questions? Okay. So you can see tangent is one of the harder ones to work with because of it. We got a fraction over a fraction. Sines and cosines are not so bad. It's just a fairly simple function. You put them in, multiply it, and usually we have a common denominator, so those are nice and easy. Tangents are going to be more difficult. I'm still not sure if it's correct. Sometimes you could also try like the tangent without rationalizing the denominators and see what happens, but if we're going to rationalize, I'm thinking it's better to do it at the beginning, and then as you can kind of see, if we didn't, the denominator sort of canceled out anyway, but I think we're okay. All right. And this is our last example. So we can also use this if we're kind of like doing a composition. So this is a cosine of, and again, this is very contrived, but notice since this is inverse sine of some number, that is an angle, right? You plug in a value into the inverse sine, that's an angle. So this is a first angle plus a second angle. A lot of times, though, we work through these without ever knowing what the angle is. We don't really need to know what the angle is. We just need to know what the sine and cosine values for each of those are. Okay, so what I'm going to do is I'm going to label this as angle A, and this is angle B. And let's see how we're going to do this one. So what we know is that inverse sine of 2/3 equals angle A. So what if we took the sine of both sides? What's the sine of the inverse of sine? What does an inverse function and its original function do to each other? Dig the hole, fill the hole. End result, back to where you started. Okay, so and as long as we're within the, and notice we weren't given any quadrants or anything. So what we can say is that these kind of just cancel out, and so what we know is that the sine of A is equal to 2/3. Okay, so that's how we're going to use this. We're going to do like what we did on the last one. We set up the triangle, and we can find out what cosine of A is without ever finding out what A is. Okay, so this triangle, again, we'll just assume first quadrant because it's positive, right? So our triangle here is, bless you, is opposite over hypotenuse. So that's going to be 2/3. I think this will be what, square root of 5? 3 squared equals 2 squared plus adjacent. Yeah, that's the adjacent squared. So that's 9. 2 squared is 4. 9 minus 4 is the adjacent squared. That's 5, so this has to be square root of 5. Okay, so use the Pythagorean theorem to find that other side. And as you do these, you'll start to see these similar ones come up. So, hypotenuse is 3, 2. So then what that allows us to do is cosine of A is going to be square root of 5/3 is adjacent over hypotenuse. Okay, we don't need to get the tangent on this one because we know that we're only we're only dealing actually with cosine, so we just need to find that. So we need these two, so we're getting there. And you might, if you wanted to, you might want to go ahead and put out the formula to see what you need. But we've got the sine of A, we've got the cosine of A. We'll do the same thing over here for B. So thinking of this cosine inverse of negative square root of 5 over 4 is equal to B. We take the cosine of both sides. Gives us that cosine of B. And notice the cosine sort of cancels, is equal to negative square root of 5 over 4. If cosine is negative, which quadrant are we in? Second, right? Because first quadrant would be positive, second, and that fits within the domain and range and stuff of inverse functions, so we know we're in the second quadrant, so we're going to expect sine to be positive. So that's why we just kind of sometimes have to place ourselves again. So if we're in the second quadrant, we draw our triangle over here. We know we've got the adjacent over the hypotenuse, so that's square root of 5 here. The 4 goes there, so to figure out the last side over there, let's see, hypotenuse is 4, so we've got 4 squared equals square root of 5 squared plus, that's the opposite, OPP squared. 4 squared is 16. Square root of 5 squared is 5 plus the OPP squared. So subtract 5, that'll give us 11. Is the opposite side squared, so square root of both. So the opposite side is square root of 11. And so then we can say that the sine of B, and so the square root of 5 is negative, square root of 11 would be positive because it's going up, so that's going to be square root of 11 over 4. Okay, so I've got these, I've got all the things I need. Now I just use the formula, turn cosine of A plus B, right? Cosine of A plus B is going to become cosine, cosine, sine, sine. Cosine A, cosine B minus sine A, sine B. And again, I'm still a rookie, so let's go back. Cosine of A plus B, cosine, cosine, sine, sine. Okay, and with the subtraction, the opposite sign in the middle. Okay, so I've got the formula set up correctly. Now I just plug in. What is cosine of A? Oh, that came over here. That's square root of 5 over 3. What's cosine of B? It's over here. That's negative square root of 5 over 4. We subtract what's sine of A. Sine of A is over here, 2 over 3. And what's sine of B? That's over here. That's square root of 11 over 4. And notice nicely we're going to have a common denominator. So this one, when we multiply square root of 5 times square root of 5, positive times a negative gives us a negative 20. Oh, no, not 25. Square root of 5 times square root of 5 is 5. It could go in between. It would be the square root of 25, right, which is 5. So this becomes 5 here. 3 times 4 is 12. And then we got 2 times square root of 11, which is 2 square root of 11. 3 times 4 is 12. We got a minus and a minus. So that's just negative 5 minus 2 square root of 11. All of this over 12. Again, we still don't know what these angles are. However, we have a little bit that we're adding two angles. The first angle in the first quadrant, because it was a sine, would either be first or fourth quadrant, right? Since it's positive, it's first quadrant. Second angle is either first quadrant or second quadrant. Since it's negative, it's second quadrant. So we have a first quadrant angle plus a second quadrant angle. We could still be in the second quadrant, or we could be in the third quadrant. We're not really sure because we don't know what those angles are. But this is a cosine, and notice it's negative. So either way, whether we were in the second quadrant or the third, we would have a negative angle. Okay. So what time is it? 10 o'clock, so we still got like 15 minutes. But that's the last example we need to do. And what you'll see is that it's got this new thing of the sum formulas that we use, but we're having to dip back into things we did before with inverse functions and knowing one value, how do we build a triangle to get the other. So there's some good review built into this, and then we apply it to these formulas. What we'll do on Thursday is we'll do double angle and half angle, which is an angle added to itself. So it's you'll see the formulas are similar, or it's a half angle. You could have, I guess you could think of it as subtraction or some way, but it'll be similar along these lines, but the formulas are a little different. And I think some of them are a little easier. And remember with trig, since we're dealing with the circle, there's more than one way to do things, and you could actually come up with more than one right answer, but this allows us to get some exact values for various situations. But remember, a lot of this is not where will I ever use this, probably only in a math class, but it's a skill that you're going to build up that will allow you to solve certain problems down the road. Okay, but in themselves, the homework problems are mostly practice just using the formulas and using it, and then later on in an applied problem you will find a place where you can use it. Any questions? Does it seem somewhat clear? Yeah, have to work through it. Very good. Again, get those formulas to use them. We will provide those later on, and if you'd like to hang out, yes. It doesn't matter, because when you solve for this radical 11, you could have it, but if you square it, it's going to become positive. Right? So it'll become positive 5 either way. But yes, maybe good practice would be to have it as negative because you know it is, and then square it. But sometimes you can get sloppy, but sometimes you can't. So if you're not sure, yeah, go ahead and it would have been good to put it in there. Good question. Good question. Yeah. She was saying because here we have a negative, this one, we have a negative square root of 5, so when we plugged it in here, we have had negative square root of 5. And technically, yes, but there's a parenthesis here, so when you square it becomes positive anyway, but it's, again, that's where I usually will make my errors, and sometimes I should have had it there and I didn't, so good call. All right. So if you want to hang out and do some work, that's fine. If you want to head out, that's good. Thursday we'll pick up with double angle formulas.